Hello everyone, good morning and good evening. Based on the time zone you are, Parminder here. Welcome to session number 2 for Simple Logistics. I hope every one of you can hear me clearly and you are also able to see my screen. If you are facing any problem to hear me clearly or to see my screen, please drop a note on the chat window. We will be quickly revising what we have done in our last session and then we'll proceed ahead where we have left. So basically, in the first introductory session, we see that what would be included in the training, what kind of the topics would be there. And then in the next sessions, the last session, we have gone through about the key problem, the key questions we have related to the HANA database and the motivation to do the HANA database. So we have seen a use case where basically our target is to deliver in the 7 days, and we have seen how it is very complex with the current IT ecosystem, how the drawbacks are there, and what are the processes there which is lagging to support the innovations. And then we discussed that how SAP has identified all of the key areas, and then they have decided to move to SAP HANA to provide a new database, to provide a new infrastructure to resolve all of our problems which we face in operations. Then we went to the history of SAP. We saw that how SAP has started from the R2 and done the different progress and different improvements, and the current innovative product is S/4HANA. Then we discussed in detail that what kind of different SAP HANA products we have. We have Suite on HANA, we have SAP HANA, S/4HANA, Simple Finance, and BW on HANA. So we discuss in detail that how the progress happened for all of this and how these different products, what are the features are there for all of these different products. Then we discussed that the driving and the motivations for the HANA. The first we discuss in the use case how the processes need to be improved. That is a motivation, and this is all of the things which is basically a business is looking for, organizations are looking for to improve, and these all are the motivation factor for HANA. Another motivation factor, the key motivation factor, is data footprint reduction that we'll be discussing today. That how SAP has done a different changes which helps to reduce the data footprint. Now I will take a pause here and I will ask if we have any question from our last sessions. You can ask it now. Any kind of question from our previous session or any another doubt you have from our earlier session, you can ask now. Okay, no questions, let's go ahead. So basically, first question is, why do we require a data footprint reduction? Why it is so necessary that it is a big motivation factor for the data footprint reduction is a big motivation factor, and all of the companies are looking forward it. Why it is the case? Anybody would like to throw any light here? You want to speak that why the data footprint reduction is required? Why do we need to reduce our data? What is the key necessary for it? Anybody would like to throw a light over it? Feel free to speak. I will unmute you. Yes, Ranganath is saying the data redundancy. That's correct. Data redundancy is one of the things which we have. So due to this data redundancy, we are getting a multiple datas, which is building more data on top of the data which we need to use. Well, any other factor you want to highlight? Sumit has made a very good point. Cost to maintain it. That's correct. The cost to maintain the data is also an important factor. And especially when we are looking for the new technologies, when we are looking for the new technologies, we are basically will be discussing the in-memory database. In-memory databases, especially this in-memory databases, are very costly. Compared to our traditional databases, it has a high cost. So also to when we are changing the technology, with this change in technology, the new databases we are using, this is expensive databases, so we need to reduce our data footprint to adopt that. So that is also one of the reasons why companies need to go for it. Another reason is you will see that our 90% of the data all the world has been created in last 3 years. So you can imagine that every year we are creating the huge amount of data. And one side we are creating a huge amount of data, and we are saying that the data we are collecting would be helping to basically analyze the problems and provide a solution. So that rather than the people thinking their mind on the solutions, we can put some algorithms on the data, and data would help to identify the solution for the problems. Or it can also identify the problem, it can also surface out the problems for us. So when we use these kind of terminologies, we also talk about the big data. So anything more than the 1 terabyte, generally we discuss, we call it as a part of big data. So this big data we have now, we have now bigger machines, we have now bigger software and the processes who can handle the big data and provide us some analysis out of it. But the thing is that how much of data these processes, these algorithms would be able to handle. If we are generating the huge amount every year, we'll be generating the more 50% of the data. So the systems and everything has its own capability and capacity. So these processes which analyze the data, when they has a huge amount of data, which means we need to write complex algorithms to analyze the data. Other than complex algorithm, more data means more sound. So it is difficult to find out the action from the sound if we have a more data. So where exactly we need to do the action, where exactly which data need to be used, it is very difficult. We need a lot of data scientists, a lot of business analysts to identify. Even starting a data science project, we need to identify that which set of data need to be used. A lot of effort has been put it on that. So huge amount of data means the analysis we will require, the capability to analysis will require will be huge, and it will be difficult to identify solution or the analysis from the data. So that's why we also need to reduce our data footprint. And so that was why we require to reduce the data footprint. Other than that, now how to reduce the data footprints? How we are able to reduce, will be able to reduce our data footprint, and how HANA will help to reduce the data footprints. So HANA has some key features and capabilities. And out of these key features and capabilities, one is the compression. So that is the native technology of HANA databases, that it compresses the data. So it has some batch job which run when it receives the data, and it compresses the data. So that is the native capability of HANA database. Then HANA database has a column store. So HANA database is an in-memory database which can support both row and column store. There are only few in-memory databases available in market which can do that. So HANA has that capability to support both row and column stored database. We'll discuss in detail that when we talk about row-based data structure or a column-based data structure, what actually differentiated in both of them? What are the key differences in both of them? So the column structure also reduce the data footprint. So when we store the data in column, system remove the duplicate values, and again data is further compressed, which helps to reduce the data footprint. Indexes is the key part. Indexes also, do you know what do we mean by index? When we talk about index in SAP, anybody would like throw some light over it? What is index actually? You will be hearing it a lot in the SAP presentations if you have gone through our videos for HANA, that now the indexes is not required, aggregate tables are not required. But what is the index? What is the aggregate table actually? Anybody would like to throw some light, put your views on it? What is the index? Yes, we have one answer that indexing helps to improve the database access. What else? What else? What actually index is? If you want to define an index, how we will define? What do we mean by index? Raise your hand if you want to speak. I will unmute you. Yeah, Umesh, go ahead.
Yeah, index is basically kind of same column or through this we can sort out the data. So when we have to be suppose I'm searching some data, so first it goes to the index and it find out like subject line or something, and then after we are going to the actual data. So index basically sorted out data.
Yeah, that's the right statement. Index sorted out the data. That's correct. So if I need to explain in a layman language what an index is, so index is basically we read the books, right? And when we read the books, the first thing in the book is index. So let's say you are reading a book and the book doesn't have any index, and I ask you to find it out from that book what it tells about HANA. So if the index is there, you will straight away see from the index which chapter has this information related to HANA, and you will go to that chapter, right? But if the index is not there, what you will need to do? You need to open the book and go by page. You need to scan the whole book page by page because you don't have any index. And there can be cases that the information about the HANA is in the third chapter and the book has 20 chapters. So you find the information in the third chapter, but you still need to go into the further chapters because you don't know whether the last chapter also has that information or not. So let me quickly explain you here. Let's say we have a table and that table has a sales order number, item, plant and quantity. So I'm just writing this 4 or 5 line item, but columns there will be more fields to it, and it has a sales order 001, 002, 3, 4, 5, and item 001. Then it has a plants K001, K002, K001. So I'm writing just 5. There will be 1,000 of rows like that. This is quantity. So what will happen if you want to, you put a question to your database, which is a kind of a row kind of a database. You put up a question to the database that you want to know the quantity sales, open sales order quantity for plant K01. You ask this question to the database. So what database would be doing? They start searching it. If there is no index, they start searching it. First, second, third. So when they come to third, actually, after doing all of the search, they have already result, but they will be keep on going. So if there are 10,000 rows are there, they will be keep on going to identify the information because there is no index there. But if you put an index on K001, then system will find a file which has already sorted for plant. So then when system will be having only 2 line items for this case, 001, K001, 50, and 1003, 001, K001, 200. So system will be only reading 2 rows here if the index is there. So what index is doing? It is improving our read efficiency. So if it improve our read efficiency, then it is good, right? But what happens when it improves the read efficiency? Each index is basically a copy of table. So when we create an index, what actually we do? We create a copy of a table at the backend. So each index, when you create, if you have created a 5 index, actually you have created a 5 new data sets, which will be at the back of the database. So database will be having a new data set. So basically what we are doing, we are creating a redundant data, and but we need to improve our read performances. That's why we are doing it. So that is what index is. So what SAP has done, basically SAP will go through in the next set. We'll go through that why these indexes were actually required, why we need to go with the indexes. We'll go with the history of the databases, that how the databases evolved, how our data model evolved. So we'll discuss more about that. So what HANA has done is they have removed the indexes. How an index has been removed in HANA? Basically due to the column store. So in column store, each column act as an index. Each column is an index in a column store. That's why we don't require indexes. That's why we don't require indexes in our HANA database. So when we said that we remove the indexes, we again remove the duplicate tables, redundant tables which has been created. And then putting OLAP plus OLTP together is another key. We have bring up online analytical processes on online transaction processes. That is also the key part to reduce the data, because what was happening, our current system was good with OLTP, but we also need great online analytical processes. So we create altogether a new system, a BW system, which takes the data from our current system in the match job, and so this is the total duplicacy of the data. So if we combine OLAP and OLTP together, we can basically remove this data set altogether. And we can also remove all our aggregated tables. So basically, aggregated tables are what? Aggregated tables are tables which has been created through our parent table by aggregating the data. So basically, we require to have aggregation of the data at the partners level to find out the quantities and the furthermore aggregations we require. So that aggregate data also uh, maintain in a separate tables which contain again a more data. So that aggregate tables has also been removed to reduce the data footprint. So we'll go in the system to check what are the aggregate tables are there, how to check them, and how to check the indexes, whether it is there or it has been removed. So after a couple of this, we'll go ahead in that. So basically, to simplify the data model, SAP has removed the so the concepts which we have discussed so far, we have removed from 593 GB to 118 GB. Okay, so to reduce further, SAP has reduced all of these tables, which is not necessary. All of these aggregate tables, which basically doing the aggregation of data, are not necessary. So SAP has removed, a lot of simplification has been done, a lot of tables has been removed. So due to that removal of these tables, we have reduced the data, we have simplified the data models. We have combined some small tables and again made a big table, like the status table has been removed and put it into the main tables with the header or item tables. So a lot of these kind of improvement has been done. We'll discuss all of these improvements when we go into our simplification session. So by doing these improvements, we have reduced further to 42.4 GB. Now, if you want to reduce it further, the further reduction has been done by implementing the technology which is called historical data and the actual data. So basically, HANA has a capability, we'll discuss this capability in detail in upcoming session, that it can store the data in the different layers. So this layer is called as a hot layer, and the data which has not been used, system put it back to warm layer, and then there is a cold layer. So system can manage the data into the different layers. So the hot layer is basically our in-memory database layer. So by using this historical approach and by putting the data in different layers, we can reduce basically our in-memory, our warm memory we can reduce. Now, is there any simplification possible that we can reduce further from 8.4 GB? Yes, there are further simplifications available which can be done. So I was working in a previous company in a project where basically what we have done, we have created a new data model on top of HANA. So our data model which we have created by using HANA was data model which is called event-oriented data model. So the previous slide we have seen that SAP has reduced the table, right? It has been simplified. But when we have said that SAP has reduced the table, SAP has a thousands of table. It doesn't mean that each table has been simplified and we have removed all of these tables. So basically SAP identified that only the top tables which is impacting our database a lot. So simplification is just the start. So in this start, SAP has identified the top tables, which we used a lot to derive the reporting part from our transaction processing. So those tables has been targeted and simplified first. So you will see a lot of tables related. Still, you will see a lot of tables into HANA database, like our tables related to uh, configurations and many another table which doesn't have a much impact on our database performances. That tables are remain as is. System SAP has not touched them for yet, but in future, wherever the scope is there for simplification, in the next version the more simplification would be done in the data model. So basically they work on the Pareto kind of thing, where they identify that what are the top 20% of the tables which has a 80% impact. So the target are those 20% which is having 80% of impact. Now with event-oriented data model, basically what we have done, we have stored the data based on the event. So rather than a sales order, purchase orders, process order, everything is created as an event. An event has been defined into the system, and then we came up with a very simple data model which has only basically 4 tables. All the data is stored only in 4 tables, and then some supporting tables. So altogether within the 10 to 12 tables, all of the data has been maintained, which can help for reporting purposes. So we have a table related to header table, which has all of the header related information, whether it's a sales order, purchase order, process order, maintenance order. We have a table related to when, which has all of your dates. Then all of our quantity and amount is in one table. And then all of attributes, our master data attributes and other attributes like sales org in another table. And all of these tables are linked with the unique IDs. So this is very advanced data model. In one of our Sapphires, we meet the director from HANA, HANA director, and she said that this is the model which SAP is also looking to adopt, but they will be going with this model to reduce the data further by 2025. So 2025 will be having another simplification, another innovation in the data model, where the data model will be further simplified to adopt to the event-oriented data model, which will reduce data further and which will reduce the count of tables further down, and we will be able to have we can imagine that we would be able to have around 200 to 500 tables, all of the data stored. So that is basically the event-oriented data model will be the future, which will be coming after 2025, which will help to reduce data further. So that is basically the data footprints, which the strategy to reduce the data footprint, how we have removed the aggregation tables and our index tables to reduce the data. So we have one question. In event-oriented data model, table is customized table. So basically the event-oriented data model, the table is totally different, the kind of tables we see. So when we say the table, it would be it would be one table which will be handling all of the events. So how system handles the events? Let me try to explain you. Let's say we have a sales order creation. So SO creation is one event which we need to define. So the whole data models need to change. Our coding will also need to change to adopt that model. So SO creation is a one event which will be having a set of data with it, which will be having a quantities. Quantity will go to the quantity table. Dates will go to the dates table. Okay. Then there is a credit release happen for the sales order. Now the credit release will be again another event. So all of the things which is coming with credit release, the date which has been released will again go to the date. The quantity amount will again go to the quantity amount table, and the attributes, let's say customer, our sold to party, shipped to party, sales org, sales area will be in one table associated with that event called attribute table. So you will not find this concept anywhere because it is for SAP side. They have not launched yet in their roadmap yet. It will be coming by 2025, a very far future. But just to show that we have further opportunities to have some new data models to come into the picture. So when the new data model, these tables will come. It is not like a configuration table. It's a new table in itself, in which we need to define the events, and it will change the whole data model, which will also require to change the coding part to adapt to that data model. I hope it answers your question, Umesh. Okay, let's go into the system now and let's check. So for all of those who has already enrolled for the training, we have a system access. After this session, I will be sharing an email with you, which will be having details related to remote desktop, how to log in into that, and what are the steps you need to do to log in. And once you get that email, go through the remote desktop, try to use the system, try to log in to your SAP system, and then reply back if you are facing any problem. So this is basically our remote desktop. In this remote desktop, you will find here SAP logon. There is an icon here for SAP logon. Here we have two systems. One is 1610 system, another is ECC system. So let's log into the 1610 system. You will have your own user ID password, use that. So once you will be logging into the system, there can be chances that you will see the screen's not like the same as I see. So you need to do some setting change. Now we have an option, because you know that SAP is moving forward with the Fiori approach. So SAP now the new GUI platform also has a feature which can modify your screen, the GUI screen, to look like the same as a Fiori screen, as a web model. So what you need to do, you need to go here, custom layout, go to options. Here we have a different themes, and here will be their accept SAP Fiori visual theme. So if this is selected, the whole screen layout will change. If I click on apply, if I click on OK, then I need to exit from the screen. You can see that the layout has already been changed. So everything is written here now. You don't see the icons here, the earlier icons to open a new window, to do all of the stuffs will be having an icon. There's no icon. Everything is written here. If you go ahead in any transaction, let's say VA03, if you see any order, you will see totally new kind of screens here. That is basically Fiori enabled screens. It's the same GUI platform, but it gives you a feel of Fiori. So if you see that, and if you want to change it, you need to go here, more, SAP GUI setting and actions, options, and deselect this, accept SAP Fiori visual theme. Apply, OK. So we need to again restart to change the theme. I have explained because once user login first time, we receive a lot of complaints that the screen is not familiar, a lot of icons are missing. So if you see the Fiori screen, if you want to change, you can use that option to change your screen. Now let's go and see how we can see whether the indexes has been removed or not. So we go into SC11 transaction to check table. Let's say VBAK table. We click on display. Then we click on indexes. So you will see here the indexes, and it has been excluded from the HANA databases. So you can go and check the indexes for the different tables, and you will see that the indexes has been excluded for our HANA database model. So not all of the indexes has been removed, but most of the indexes has been removed. Some of the indexes has some technical significance. That's why SAP has still put it, but most of the 98 to 99% of the indexes has been removed. We can also use the table for indexes, that is DD12L. Here we can put the table name. If you want to check, let's say we put a Mara, or we can also run it to check in general about all of the tables indexes. So it has in general tables, and you see that all of the tables indexes has a status excluded from HANA database. Let me update that table in our notes. The table we have used is dt12l to check indexes. Now here, when we are in the screen, let's also check some other things. When we say that the tables has been removed from the S4 system, it doesn't mean that you will not be able to see those tables. Let's say we go with one of the table, one of aggregated table, which is VAK PA. We go into display. Here you will see the table, and if you go into the extras, you will find one thing here which is called Proxy Object. So if you click here in this Proxy Object, you will be able to find view which has been created for that table. So that table has been removed, but you will be able to access all of the things in SC11, SC16, but actually it is not a table. Now it is a logical structure which is called as a view in S4HANA terminology. So if you click here in the Proxy Object, you will see here a Proxy Object has been assigned to is v underscore VAKPA. Okay, so what is this? This is basically a view, or actually it is a CDS view. What is CDS? Core Data Services. So what this view does, it creates a logical structure and it connects us to the main table. So the data would be there in the main table, and the logical structure would be there. So the benefit of this logical structure is, earlier in this table we will be having a data. So there was the data in the main table, and the aggregate tables or in the index tables were also having a data. Now the data is there only the main table, and this table, this is not a table, it's just like a view which will not store any data. Only user, when they will access it, then system on the fly, this logic goes to the main table, bring the data into this table and then show us. And when we will come out from the transaction, again this data will be deleted, which has been shown through the logical structure. Okay, so CDS views are nothing but a logical structure which combines a different set of tables, a calculation logic, aggregation logic on top of that, and it sits there as a program code. And that program code is basically written on SQL through HANA Studio. So that program code, when we will be triggering that program code, then only it will be bringing the data via calculation through the main table. Otherwise, it will not store any data in these objects. So if you are in the system, if you want to check whether a table has been removed or not, which table you are looking, whether it is a view there in the database or it is there as a database table, you can go here and you can check it whether a proxy object is assigned. If a proxy object is assigned, then it is basically a view, not a database table. So I will do that activity once again so that you can follow the steps. Let's check another table. Let's check MARDH. So this is kind of a historical table for material master storage. So all of the historical tables has also been removed and created as a view. If we go again in extra, proxy object, system tell us this is a proxy object, nsdme_mardh. So this is basically a CDS view. If we try to execute this CDS view in SC11, system will ask us to go to ADT in Eclipse for processing CDS view. So ADT is basically a BAP development tool. This is a BAP development toolkit. Eclipse is basically a platform which has been used by SAP on which HANA Studio has been built. So HANA Studio has been built on a platform which is called Eclipse. So system is saying that if you want to view a CDS view, if you want to change anything in the view, you need to go to HANA Studio, and then from there, by using a BAP development toolkit, you need to do the changes or view. So CDS is also called as a BAP on HANA. ABAP on HANA is nothing but how to write SQL codes which is directly linked with the database by using ABAP lifecycle management. So it is basically SQL using ABAP lifecycle management. Any questions here? Yomesh, go ahead. I have unmuted you. Can you try to unmute yourself?
Yeah. So every time it is we need to first create this views, right? Then we can check in table.
So we need not to create. So these kind of views which we are right now seeing, these views are actually created by SAP. SAP, when they give the system, the S4 system, they have already created these views, and when you go to S4 system, you get a lot of these kind of views which has been created by SAP. On top of that, if you want a new reportings, okay, then the new reporting is suggested to develop a new CDS view.
Yeah, suppose if I not remember, so this is a path we need to follow and like take these views, and then again we are going here in database and we can check the tables, right?
Yes, that's right. So basically this path, as a functional consultant, you are supposed to use so earlier we were using a tables, right, in our functional specs which we want to write to build something new. Now the SAP recommends, rather than using the table, we should use this view which is linked with that table. although the table will also work, but the best practice to call the things from the view.
Okay, and the same view can it can be normally what happen, we have to be couple of table using in a program, and through this there are some data is flowing, right? Some couple of functionality. So in that cases, instead of doing using the table, we can use the views as well, right?
That's right. That's right. HANA has also capabilities where the function consultant will also be able to do the creating the views. So let me explain that part to you. So with the HANA Studios, so there are the two parts. We have a CDS part. Let me explain it here. So we have a CDS part. CDS view currently are done by the technical guys because there is SQL coding required for it. Then there are the another views which is created through the data modeling. So we'll be going in the data modeling class. We'll understand how to create a data model by HANA Studio. So in this data model, we can have one table and we can have another table. We can link them, link both of tables, create a view. So the SQL code for that will be written automatically in background. So that is a tool which can be used by the business analyst, can be used by the functional people to create view. Okay, so there are two kind of view, data model views and CDS views. For S4HANA, we can use both, but generally we go with the CDS view. That is the more recommended. We'll go in detail why the CDS view is more recommended than the data model view creation. But this one is also used. And now this is actually a kind of a flagship runner or kind of a very famous tool to do the data modeling, this data model. Because there is another scenario other than S4HANA which use this. We'll be discussing them in detail. Now this CDS also SAP is working to give us a graphical model for CDS. Rather than writing a code, we'll be having the same kind of functionality in future to create CDS view. So in future, functional consultant will be able to directly create a CDS view by mapping the tables. A view will be created which can be directly consumed in Fiori or in another applications, and the report can be generated. So there are some tools available with the HANA Studio where basically the key selling feature or key selling point for them is that the reports can be generated without the IT help. So we'll see how a functional consultant can create a view, and then that view can be consumed directly in the BI tools to generate reports. So that can be done. Mish, I hope it answers your question.
Yes, Dharmender, yes.
Okay, we have one more question. Sorry, we have one more question from, let me check that question. We have one more question from Ranganath. What's ABAP lifecycle means? Okay, so I told that the ABAP lifecycle CDS views are basically the SQL maintained with the ABAP lifecycle. So ABAP lifecycle is nothing but, we have in ABAP model, we have a model which can define the objects. So ABAP objects are there. So we use the same object models to create the CDS view, to create the SQL views. However, these views doesn't follow the ABAP lifecycle. It is not an ABAP object. So once the ABAP object is created, we can use the same methodology for the transportation. We can transport with the same ABAP methodology. It is on the ABAP layer. These objects are on the ABAP layer called ABAP object, and when we can use the same lifecycle methodology for the transportation to create it in the dev, to move to quality, and to move to the production system. However, this data models doesn't follow the ABAP methodology because they are on the database layer. These are directly created on database layer, and it can skip the ABAP layer. I hope it answers your question. Umesh, do you have another question? I see your hand is still raised.
No, Parminder. I'm mistaken.
Okay. So let's move ahead. So the next thing we'll be discussing now is to check the history of the database model, how the database models has been created and how it has approached. Why basically we are looking for to change the data model. Why do we require to change this data model? Let's look on that part. You all will be having access to this Microsoft OneNote, all of you who have already enrolled. Okay. So basically what happened from the starting whenever we have started maintaining the business's organization structure and doing a transaction for it, from the starting we are doing a transaction on the papers again some kind of the document number. So everything is given as a document number. So basically if you will see in the databases we have, even from the 1960s or 17 or of today, what we are doing, we are managing the documents. Whether it's ST module, finance module, module, or PP module. Everywhere we have some documents which is called financial document, sales order, process order has a process order is also kind of a document, purchase order is a document. So what we are doing is actually we are managing a set of documents. So when the databases was created initially, it was created in 1916 and 17 as a table. A header table combined with the line item table, which has many of these fields with it, which has a header field, item fields, quantities, amounts, dates, and attributes. So we created a long table up to the 200 columns in the table. And what happened when we gradually improved in the database model, we keep on adding fields in these tables. So when we added any line of business, let's say a retail business, we add more 50 fields to it in the same table to adopt for new line of business. So that table become 250. If we talk about a sales table, another line of businesses come, so table grown up and it become a 350 fields in that table. And what happened that if there is any changes happening, a historical table need to be stored. Let's say the quantity got changed, a new historical table, a new whole data set has been entered. For each change, we entered the new data set. the whole data set. Although the one field is changing, but we are entering the whole data set with each new creation of the historical table. Basically, what we are going to do is we are going to duplicate the data. So then what happens is there's a big tables. Big tables is difficult to manage, and it has a lot of read performances issues because system has to read the all number of columns when the quantities or something has been changed. We need to change all of these fields together, store into the historical tables to know that who changed the quantity, when the quantity was changed, who done the insert. So all of these things to know, we add the whole line items into the historical databases. Then we did an improvement, and when we went to the R3 and ECC, we created multiple small tables. So we created a separate table for header, separate table for item, then the statuses table for both, and then many more tables related to deliveries, related to shipments, related to schedule lines. So we have divided the big table into the small tables so that when we are going to write or when we are going to read, we have a better throughput. We have a better efficiency from the system. Now what happened with creating a lot of these kind of tables? One problem which came is that we created a spider of tables. So each table is connected with each other table. So there's a logic need to be written to understand that how all the databases is created. So we create a spider of the tables. And due to this spider of the tables, we faced a lot of problems related to locking and latching. So what happened that if some table is got fixed, somebody is updating that table, we face the locking and a lot of latching issue with that spider kind of thing. And the problem becomes more because with the gradually increasing data, with the gradually in this table also with the new line of business, with the new functionality features, we added fields, we added more fields. And then these tables also become bigger and the throughput of these tables become lower. So what we need to do, we need to find it out for the read performances. We need to define some of the indexes. We started defining indexes. So we started defining a kind of a smaller table set out of it by defining index. So SAP has defined some of the standard index. Our developers and our data modelers created more index on top of that, which means the more duplicacy of data, which means anytime a change need to happen, we need to sync all of these tables, all of these indexes table. Then to improve the further efficiency of the transaction processes, what we have done, we have created the aggregate tables. So with the indexes table, now we created aggregate tables which can aggregate or sum of some of the quantities, amounts, and then give us the data. So we created multiple aggregate tables for it, which means we created more and more data. So we have complex the whole structure by using that. We have indexes, multiple indexes, we have a multiple aggregate tables which has been created to support our analytical processing. And for sure, for this one also we have historical tables which need to store all of these line items. Although it is reduced from here, but still with the growing requirement, it also has a significant amount of data which need to be replicated if any field got changed here. Now what happened with all of these complex structures which we had in the system? What we require a very high knowledge of any people working with these databases to understand logics and the linkages. So any functional consultant or the developers who wants to work with these data models, they need to first understand how the different tables link with each other. So that increases the complexity of the system, which means our quality of the code need to be very good. Okay, and it has to be revised multiple times because of the complex structure, and it required a detailed testing. Any new code require a detailed testing. And basically what we have to maintain all of these aggregation tables, we have a code enter to it to maintain it. So there's a significant amount of code in our system which is used to maintain the index table, which is used to maintain the aggregation table, which is used to maintain this whole spider architecture of our data model, to which is used to maintain the linked tables, and to reduce the locking and latching we have another set of code. So we have a lot of code, junk code into the system, which is only used to maintain this complex data structure. So what problems we have here? We have here duplicated data, and still after putting all of these efforts, still our analytical processing is not good in our current systems, even though we have created the index tables or the aggregated tables, but still our efficiency are not that good to read the data what required by business. We doesn't match that one. So then SAP has come up with the new data structure. They understand that the whole data model need to be changed, and they come up with the column-based structure. So here in the history, you can see that what we have done, we had a big tables. We defined small tables. Now again, with the HANA, we are going with the concept of big table. Because what was happening, the kind of design which was put there in that era, it was kind of one of the best design available. What the developers, what the data modelers, what the data administrator can do, they have put the best design. But because at that time we don't have any technology which can handle those big data sets together. Our old data servers, our old databases were not able to capable to handle the big tables into the system, to put it a logic on that, to do the aggregations on the fly. So all of the capabilities are not there. Now when with the HANA, we are having that capabilities with our in-memory system. And with the column-based storage, we are going back with the big tables. We are going back to join the tables and create one big table which can be accessed, so that we can remove all of this locking and latching kind of issues, all of this spider net of complicated data store. So now what we have done, we have defined a big table. Again, the difference between that big table and this big table is that table was basically a row-based structure, and this table is a column-based structure. In column-based structure, each field acts as a different segment. Each column acts as a different segment. So if we do some change here, we need to only replicate in our historical table that change, only that field change, not the whole table. So you can assume that when we have around 200 or 300 fields in a table, to change one field, we are replicating whole fields. Here we are only replicating one. And here we need to only locking and latching also reduce, because when we are locking a table, actually we are reading only one subset, one column of the table, and the time is reduced to update the table and to make it remain locked. So within the nanoseconds, that process can be done. So that thing also improved with this column data storage. Now this one in the column data store, basically each of the column act as an index, because each of the column is stored as a different file set. So we can do the search on each of the column. Each column work as an index. So there is no requirement of the index table. And because it's an in-memory database which has a high speed to read the data. So due to high speed of read the data due to the in-memory database capabilities, now system can read through this the whole table, and if any aggregation required, system can do the aggregation on the fly. So earlier on the fly aggregations was not possible because our existing database, which is based on a disk and RAM, was not able to efficient even to fetch the data to the application layer. It was lagging there. But with the in-memory database, which is a high-speed database, we are able to aggregate data on the fly. So which means we don't require aggregate tables. So what problems we have solved by this HANA databases? And to do that, we have not only the model, not only the data model has changed, but also a rewriting of code has been done. We need to rewrite the code to adopt the new data models, to adopt the new tables, to adopt the new objects, to fine tune the things. We need to write down the whole CDS views. So a lot of things has been done, which is done in S4 HANA. So that's why S4 HANA is known as the biggest change in the ERP technology by using HANA, which is a complete new innovation of ERP. So what innovation we have done and what problems we have solved? We have solved by using our new data model on top of HANA by using the SAP HANA capabilities. We don't require any index table. Index tables are not required. Aggregation tables not required. On the fly calculation or aggregation become possible. Locking reduced. Time to reduce lock a table is reduced. Read performance increase because of the column data store. We'll go in detail of the column data store, that what technically it does to do all of these things. So read performance has been increased. So by having all of these advantages, basically we have moved to a new database model, starting from the history, from creating a big tables, dividing into the small tables, then creating an index, then creating aggregate tables. We have reduced all of this complexity with SAP HANA, with the column-based data store, and taking all of these advantages. I will take a pause here to check, do we have any question on this table on the history of databases? Next thing we are going to discuss is basically how does our current architecture is there? How does the current architecture work for SAP? Why we'll discuss about, basically the first thing we'll discuss about our existing database, why the existing database is so slow, why it cannot respond, what are the key things which existing database doesn't have and we have an in-memory database. We have one question, what does What data does column hold? Will you show an example of an SAP table to explain what data does each column hold? Yes, so basically each column, when we see, we'll go into the detail of this row-based data structure and column-based data structure, and I will show you how it stores the data. But all of this thing which we are discussing here, it happen in the background. So you will not be able to see the data that it's stored as a differently from front end. Front end, you cannot see that how the data has been stored. All of the processes happen in the back end. Okay, but I will show you in the conceptual phase that how a column-based data structure store the data. If we go into the front end, if you use your transaction like SE16, SE11, whether it's a row-based table or a column-based table, you will see same kind of output. There is no different in output. But at the back end, how system operates and how system store is different. We'll discuss that. But from front end, we cannot see that. You can write down your question, whatever question you have. I'm just taking a 2 minutes break. I will be right back in 2 minutes. You can, by the time you can write down your questions, what you have. Hey guys, I'm back. Is there any question? Let me check. Okay, we don't have any new question. Now the next thing we are going to discuss is basically architecture. How our current architecture is there and what are the things which we have in the current database, why it cannot support. Now what's happening in currently, we have a user. So basically what's happening in the current database structure is our user asks the queries to our current system through GUI. So GUI is our front-end application. So any T code has been asked by user goes to the GUI system. And after that, we have a next layer, which is our ABAP dispatcher. What is ABAP dispatcher? It's nothing but it's our application server. In a three-tier structure model, it's our application server. So once the request came from GUI to the ABAP dispatcher, our application server work on that, and we have a different work processes. So we do a different work processes. Our ABAP code run on that requirement to analyze that what is required, and it break down that into a sequential mode of the queries for which it requires the data. So we have here the processing of our code happen here. And then it sends the requirement to database. So this is our database. So within the database, we have a different layers. We have a layer for database itself, and then we have a one more system inside the database system, which is called file input and output servers. So the traditional database is little complex. We have one more structure here. So here basically the structure is where we have a file system, and then that file system is connected to the actual database, which runs on the disk and RAM. So this is the physical storage we have. So from the database layer, it goes to the file system. In file system, it has to do the operating of that what the things are required. Then it go with all of the input and output processing to fetch the data from this physical system, physical storage, which store the data into the disk and RAM. So that part is basically the part which consumes a lot of time, and it also uses a lot of CPU cycles because the data has been stored in a mechanical device. So the input and output processes we have when the data comes to the first layer, and this first layer of database from the file system is ask the data from the physical memory, and then physical memory reply back. In each place we have a different caches here. File system has their own cache, then this layer has their own cache, and here also we have one cache. So the cache is nothing but a temporary storage of data. So we have a different storage of data happen, redundancy of the data happen in all of the layers. And then this input output process is the biggest burden on the database to fetch out the data from a mechanical device. So once all of these things happen with the file system, we got the data from the database. It come on the our ABAP layer again. And here what system does, whatever the data is required, it just throws the data to the application layer. Now all the work related to the filters on the data, aggregation of data, your summing up and other things, business logic on the data, calculation logics has been done by this application server or application layer. So once this processing happen, then there's a lot of data which has been sent through the database, which sometimes is not required. So we are sending additional effort, we are putting additional effort to fetch the data and to send it. And when it goes to the calculation, filters got applied with the ABAP layer. Only the few set of the data has been used and the results have been formed. And that result is given to our front end where user access it. So this is our current architecture with our traditional database. Now, what is the problem with this traditional database? The biggest problem with traditional database is it's using a mechanical device. It's using a disk and drum which store the data. So basically this kind of systems was known as for their transaction processes. For the OLTP kind of thing, online transaction processing, where we need to write it, it still work okay. The write performance is still okay, or the load performance is still okay. It's not great, but we can say okay for them. But the read performance, when it goes and fetch out the data from the traditional system, its read performance is very poor in this landscape. Any complex calculation we need to do, any complex algorithm we need to do, any big amount of the data we need to fetch it out. Because when we write the data, we write into the small amounts. When we read the data, we read it in the big amounts. So the read part is very poor. So that's why in the current processes, what we are doing, we are only using the system for the online analytical processing, online transaction processing, not for the read one, not for the OLAP one. OLAP functionalities has not been used. Why OLAP is not used? Because of this burden on input and output and the file system in the current database we have, in the traditional database we have. Now, so that is a drawback, but it also has some good things in the system for this system. So this persistent layer, this is called the persistent layer. Because the data is stored in a mechanical device, we never lose the data. Even if the complete power failure happen, in that case also we don't lose the data. So that is the only good part here. In the persistent layer, we never lose the data because it is stored in the physical components. Now what happened in this architecture, what we have done, so we found it that okay, transaction processing is still happening. We are poor in the online analytical processes. So we created a new model for the online analytical processing. So what is the new architecture we have used for the analytical processing is we are having our GUI system, which is linked with application server, and then this is linked with database. So this is our GUI front end. Then we have our ABAP application layer. This is connected with our traditional database, which we basically use for all of our transactional processings. So we do all of our online transaction processing from here, and the small kind of reporting is also done here. Our initial reports, the small reports which doesn't consume much memory, we use here to do the online analytical processes also. But the system is basically doing the online transaction processes. Now we need another system which can run the transaction analytical processing. So what we have done for that, for the another system, we come up with a new database. We said that let's don't put that amount of load in this database. Let's create a new database. So we created a new database here, which is our BW database. Now BW database has its own BW application layer, and its own front end. So now we have a BW front end, which links with the BW application layer, which links with the BW database. So that is altogether a new database. So what happened in the new BW design? We did more complexity. We need to connect both of the systems. So we uses data from database using a BAP application layer, connecting our BW layer, and sending the data to our BW database. So we have done all of this connection. We have replicated data from here to here on daily basis. Then our another set of code run on top of this BW to give us analytical processing to the BW front end. So we are running OLAP here. So basically this part we used only to use our OLAP system, analytical processing. This part we used to do the transaction processing with the very minimal reports. Now we have a complex structure here where we have a BW, we are duplicating a data, and you can see that both of the databases which has been used are basically traditional disk and drum databases, which has a limited capabilities. So that's where we have created a two different architecture to use the two different databases and a huge amount of duplication of the data. So that is basically our current architecture of our ABAP system, our current ECC system by using a traditional database. And when we have a BW come into the picture, how the things work. Now, how an in-memory database can reduce these efforts? How an in-memory database can help us to reduce this? So basically, in-memory database is what? Any idea? Anybody want to highlight throw some light? What is the in-memory database? Feel free to speak. If you know what is the in-memory database. Now we'll be discussing in-memory database. We discuss about the traditional database. Yeah, go ahead, Umesh. You can unmute yourself.
So normally right now we have discussed about the traditional database where we have two layers. One is actually the one database layer and one other one is a no W um, like a BW database, right? So one data we are processing online transaction, another we are doing the analytical process in two different layers, right? In memory database, what happens? Within the one database, we are doing the online transaction as well as we are analytical side, whatever we have to generate the reports and everything within the same database.
That's right. That's right. So that is the basically the usage of in-memory database. So let me technically tell you that what exactly the in-memory database is there. So basically, when we talk about in-memory database, the key difference is this is our in-memory. The data is not stored in disk. There is no disk used to store the data. Data is stored in basically capacitors, electronical item, capacitors and the transistors, which need a continuous flow of charge. So we don't use the mechanical devices, we use the capacitors and transistors to store the data. You can compare your in-memory database similar to your DRAM concept, dynamic RAM, or a RAM in your computer or in your smartphones. So you can see that the bigger the RAM is there we have in our laptop or in our computer, the fast processing we have. Now what happens, you can imagine that if the whole of your computer hard disk, we consider it as a RAM. The whole your computer hard disk, you have a 250 GB of RAM, how fast the processing will be. So the same kind of thing happen here. We have created a big in-memory database which can use to store our all of the transactions, and then from the same place we can do all of the reporting. So the what are the things has been removed here? There is no file systems to do the input and output. That in-memory database can be directly used with the application layer for the read and write. Read, write. Both can happen directly from the in-memory, where it saves a lot of CPU cycles to process our another input and output. There are no cache in between for the in-memory database system. The data is stored in charge, so the retrieval of data, the output of data is very fast in the in-memory database system. That's why it is very efficient. But on the one hand, if when we say it is efficient, on the other hand, it also has some problem. Right now, make a note that we are only discussing the in-memory database. We are not discussing HANA database. We are just going through the concept of the in-memory database. Now the problem is it requires a continuous flow of charge, which means if we have a complete power failure happen, there is a chance that we can lose our data. If the complete power failure will happen, we can lose our data in memory because it needs to have a continuous charge supplied to the capacitor and transistors to store the data. If the continuous charge is not there, we can lose the data. So the data, if the complete power failure happens, the system is not stable, it can lose the data. So that is a drawback in in-memory database system. We'll discuss ahead that how SAP HANA has come up with the HANA database which can use the both of the functionalities of a traditional database and a in-memory database. How SAP HANA has combined both of the system to give us a one system which can be used by all of our analytical processes also and transaction processing also. So SAP has done a long journey for this. They have implemented many things altogether. They have acquired many companies. Actually, they are working around on from 2005 on this concept. They have already done a long journey with their a lot of homework to build up a HANA database. That's why it is much more than an in-memory database. Are we clear with this concept of in-memory database? Is there any question on the in-memory database? Umesh, go ahead if you have any question. I can see your hand is raised.
No problem, I think it's the last time I the same. That's why it's showing this line.
Okay. So let's discuss that. What are the key features are there? How SAP has developed their HANA database? So basically, what SAP has done, Sumit is asking a question. Sumit asks, can we call it as a cloud storage? No, we cannot call it as a cloud storage in-memory database, although the HANA database would be having an option to store the data on-premise or on cloud. So saying it as a cloud storage is not a correct statement because cloud storage has its own the capabilities. Cloud storage store the data on cloud, which can be used from anywhere by using the internet. So HANA, when we talk about the in-memory database can be served as a both as a cloud-based or on-premise. Now let's discuss about HANA database. So basically, SAP identified that there is a requirement to combine the both kind of data sets. So when they are going to build SAP HANA database, they found it out that they need to build a system. They need to build a system which can work with both kind of requirements, which can have a capability of analytical processing and which can also have a capability of transaction processing. So what first thing they have done is they brought it up to improve the load performances. They brought it up one system which was available in the market, that was P star time. So they do the acquisition of P star time. It is the in-time OLTP database. It is called in-time OLTP, used to improve in-memory load performance. So our in-memory database was always known for the analytical processing. There was already things available in the market which has analytical processing for the in-memory database. So it can read the data fast. It was already there. But we need also to make sure when we are using it as a ERP application, the both thing need to work hand on hand, our analytical processes and the transaction processes. So to improve the in-memory database, to improve the load performance, to improve the transaction process performance of the system, they implemented the P star time system, which was already there in the market, and it was having very good functionalities and features, which helps to store the data fast, which doesn't reduce the performance while storing the data, and it with the in-memory we already have analytical processing. But analytical processes was also improved. So analytical processes improved by using another set of system which is called Track Search Engine. So that is another acquisition has been done by SAP. With the Trex search engine is basically a column-driven reporting and computing system which has a high read performance. It is a column-driven computing engine to improve read performance. So it enhances the capability of an in-memory database to read the data. So with the Trex search engine, the capabilities to read the data, OLAP has been improved, and to store the data, OLTP has been improved. Now, another thing was the drawback was there to make it as a ACID compliance. So any database which need to support the critical business application, business application which run 24/7, it has to have the ACID compliance. So once you have an ACID compliance database, it is considered as a safe database, which can be used for any kind of business application, which is the critical business application, and it need to run 24/7. So in-memory database are having a problem that if we lose the data, if we lose the charge, we can lose the data. So SAP identified that we need one more layer here, and they created one persistent layer by doing acquisition, by doing a tie-up with Max database. So initially Max DB was used as a persistent layer. So this is a traditional database. So when we talk about a HANA, HANA has both of the components. It has a traditional database built inside it to store the data, to do the backup, which is also called the warm storage. So it back up the data into the traditional database, so that if the complete power failure happens in any case, we can quickly recover our system from the backup database, which is inbuilt into the HANA database to store the data. So SAP improved the analytical processing. They worked on the transaction processings, and they also has a persistent layer with the traditional database to make sure that we don't lose any data. Then on top of that, they added some more components here. So the other components were as added. They made an application layer inbuilt with system. So we have an application layer which is inbuilt. It has an inbuilt application layer, which is also called HANA Access Engine. So which means now you can go with the two-tier of the system where your application layer is also there inside the HANA database. So all of your processing can directly done on the in-memory database. Okay, all of your calculation processes, all of your aggregations, filters, we can apply on this Access engine. And then they also introduced some of the components called SLT. They connected, SLT was another company, they did the acquisition for that. System lens. landscape transformation or SAP landscape transformation to transfer the data to provide the data provisioning capability. Then SAP has also another engine. They have another data processing engine built. Inside this, which can quickly process the data, their own data processing engine. They have application layer there, which has the application server, and it has applications which can help you to write a code to develop an application on top of that. So you can develop an application. So it has its own library. HANA has its own library, analytical library, and library which can support you to create the application on top of that. It has their data processing engine. It has their search engine as a tracks P start time to make sure that the transaction processing remains smooth. Data can be make sure with the persistent layer it doesn't lose the data. Application server is inbuilt on this, which is called Access Engine. Data processing is embedded with it by using a system called SLT. So because it has a lot of features, it has a lot of capabilities, that's why we don't call it as a HANA database. The name given to it is HANA appliance. Because of all inbuilt capabilities, it is more than a database. That's why it is called HANA appliance. We don't use the word as a database, we call it HANA appliance because of its key features and other things. So I will stop the session here. We'll continue our session on next Tuesday, where basically we'll be moving ahead to see some more concept about HANA database, that how it can store the data into the persistent layer, how it can transfer the data between persistent layer and in memory, how it can make sure that we can take a data backup anytime. What are the different processing are there with P star time, which makes sure that the loading of the system is good. So we'll go with this basic concepts in the next session. We'll continue that, and then we'll be going to the HANA Studio to check that what application and functions we have in HANA Studio and how it can support us. So I will open the form for questions. If you have any kind of question, you can ask now. Go ahead, Umesh.
So can we check the next lecture then HANA implies how to data upload and how do we check on the layer wise? Is there any practically we are checking next lecture?
Yes, sure. So we'll be showing, we'll be working on SLT. We'll show you how SLT works. You'll be able to do some hands-on with SLT. We'll also show you that HANA has also capability that direct file upload can be done. So now when you have asked, let me show you that what kind of the data provisionings we will be handling. In data provisioning, we'll be basically showing that SLT part. We'll be showing direct upload part. We'll be showing you BODS, Business Object Data Services, and we'll be showing you Migration Cockpit, which is an advanced version of LSMW. So we're going with all of these data provisioning tools. Any another question, Umesh?
No, Parminder.
Okay, any of the other participants from, I can see Tapas, Sumit, or Ranga, if you have any questions, you can go ahead, you can ask your question now. After this session, you will be getting an email where you will be having access to the system. And I have already provided access to the OneNote and access to our drive. I hope you have that, and I can also show you that which book you can start going through. So here we have S/4HANA materials. So right now we are going through the concepts of this one, HA100. So you can start going through, you can in your free time, you can go through this book, read some of the concepts. We'll continue with the concepts of this book, which is the HANA basic concepts. So you can go through this book, and all of our videos of this session, you will find it here in the session videos. These are the session videos. I will be putting one assignment here, okay? And once the assignment has been put, go through that assignment. That is a generic assignment. Try to read it and try to do that assignment. I will put it by end of day, one assignment here. And you can use this OneNote to go through that whatever the discussions we have for each session. I have a session tabs here. For each session we will be having this thing. So as soon as I make any change here, you will getting a notification through an email that something has been done in OneNote. You can check. And here we have one page called schedule. So here in schedule you can find the schedule of the next sessions. So next session will be on 12th of June. For India time, it will be 13th June morning. For Western time, it will be 12th of June evening. You will find the link of the sessions here, and I will also put video links here. And one more link I have put it. So during this weekend, if you have, and the coming week, if you have any questions, in the links, I have put it one link for this LinkedIn group. So we have created a LinkedIn group. So go through it and try to access that LinkedIn group. I will approve your membership, and you can put all of your questions in this LinkedIn group. I will answer from there. Or if you can also send your questions through email also. Okay, if we don't have any further question, I will close the session here, and we'll be meeting again next on Monday evening Western time and Tuesday morning India time. By the time, use that time to go through the materials which we have and ask your questions through this LinkedIn group or through email. I will reply them on detail. The first thing basically in the next session we'll be going back that what we have learned, and we'll be creating some notes on our in-memory database and HANA database. What are the differences are there? And I will be basically asking you to help me to create that note. So you are going to tell me that what is the in-memory database, what is the traditional database, what is the difference between those, and I will be creating a notes for that in first, then we'll proceed ahead. Okay, if you don't have any further questions, I'm closing this session here. Thank you for joining, and we'll catch you next Tuesday next Monday evening. Have a good day. Thank you. Bye bye.